Hi all, JE aspirants and Neet aspirants. So today we will discuss all the total organic reactions. So in one video, so almost 200 reactions will be covering here total from the entire chapters. So this will be very fast only for the revision purpose. First, the reaction we are taking up alkynes are still in, so hydrogenation will be giving us the product alkynes hydrogenation. Hydrogens are added to the triple bond, so that two hydrogens add this carbon and two hydrogens this carbon. So we will get ethane is the product. And here alkenes hydro upon hydrogenation also provides ethane. So ethene, so upon hydrogenation we will get ethane. Next, so methyl iodide, so 2 moles of methyl iodide reaction with sodium. So this is the named reaction, that is Wurz reaction. So in presence of so dry ether, so with sodium metal we are getting so ethane is the product. Next, if you take instead of sodium metal, so if you take zinc metal, that is a Franklin reaction, you just remember here. Next, so ethyl halides or alkyl halides upon reduction, so with reducing agent, for example, so lithium aluminum hydride or sodium borohydride or so acid medium. So metal in presence of acid produces hydrogen gas. So those are acting as a reducing agents. So this will be displaced with a hydrogen atom. Therefore, we will be getting so this ethane molecule. Next, carboxylate, so alkane carboxylate, sodium salts of carboxylates. So decarboxylation means so removal of carbon dioxide from the molecule. So here this will undergo radical mechanism, radical mechanism, so we will be getting decarboxylation, so ethane molecule. Next, so here Kolbe electrolysis. So upon by passing this solution of this carboxylate solution, so breaking of this molecule or electrolysis, upon it will be producing methyl radical. So dimerization of methyl radical also gives us ethane molecule. Next, aluminum carbide or beryllium carbides upon hydrolysis, so produces alkanes, particularly methane molecule. So here aluminum carbide, so or beryllium carbide, carbon is having -4 charge. So upon taking, it will be taking up 4 hydrogen atoms. Therefore, so we will be getting methane molecule here. Next, eighth reaction. So here methane alkanes are very less reactive molecules. So special conditions we use. So chlorination in presence of sunlight, we will be getting so methyl chloride. So further, if you proceed or providing chlorine molecule in presence of sunlight, so polychlorination means the next second another mole of chlorine will be reacting. So it will be continuation reaction. So dichloromethane. Next, another hydrogen is free radical substitution undergo. So to give chloroform or CHCl3, then further chlorination, so we'll be producing CCl4. In presence of sunlight, we will be getting this type of free radical substitution. So free radical substitution will be having so initiation, propagation, termination steps. So at the termination, so the reaction will be ends up. So methane upon oxidation, combustion reaction, so any organic molecule upon combustion, so alkene, alkynes or aromatic compounds produces carbon dioxide, and then water, some heat is released here, combustion reaction. Next, methane, so reaction with oxygen or air uh, in presence of a metal copper at 523 kelvin and 100 atmosphere undergo oxidation. Here it is the combustion and it is completely combustion. Here partial oxidation. So here it will be giving us alcohols. In presence of molybdenum catalyst, so we will be getting aldehydes. One carbon methane is here, so we will be getting one carbon partial oxidation. Formaldehyde we are getting here aldehydes. Next reaction, So here butane upon reaction with aluminum chloride in presence of HCl and providing high heat energy and high temperature and high pressure. So we will be here we will be getting isomerization of alkanes. This reaction takes place. So here butane will be isomerized. The chain is undergo isomerization. So here butane, this is a straight chain and this is a branched chain alkane. So both are chain isomers. So we can also take here alkanes are more than 3 carbons, means 4 carbon or 5 carbon when you subjected for the aluminum chloride and HCl reaction conditions, high temperature and pressure. So isomerization of alkanes takes place. So therefore we will be getting a branched alkane, that is isobutane. Next, 6 carbon 6 carbon containing alkane when you subjected for the chromium oxide oxidizing agent, so at high temperatures. So here so 6 carbon are more than 6 carbons, so it is the alkane straight chain is cyclized and undergo oxidation, so to give the aromatized product. So if you take 6 carbon alkane, when you take hexane, so we'll be getting benzene. If you take 7 carbons, we will be getting so toluenes, and if we take 8 carbon system, we will be taking xylenes as the product. So methane reaction with steam in presence of nickel, so we will be getting a producer gas. Next, ethane upon pyrolysis reaction means so in without absence of oxygen or air. So if you heat up to 450 degrees centigrade, so undergo pyrolysis reaction. So here alkenes plus hydrogen gas is produced. So here breaking of so CH bonds and CC bonds will be taking place, pyrolysis reaction. So these reactions are covering alkanes chapter. We will go further slide. Next page. So next reactions, uh, carboxylic acid reaction with hydrogen iodide and phosphorus. So here hydrogen iodide is a good reducing agent in presence of phosphorus. So here reduction of carbonyl group, reduction of carboxylic acid group, so will be giving 2 carbon. So total oxygen is eliminated from here, so to give the ethane molecule. Next, aldehyde, 16th reaction. So, acetaldehyde or aldehydes are ketones upon reaction with hydrogen iodide and in presence of phosphorus. Also, so here reduction takes place. So, to give the ethane molecule. So, ethyl alcohol also with reaction with HI. Initially, alkyl iodide is formed, then so that iodine is replaced with the hydrogen atom. Therefore, we will be getting so ethane molecule only. Iodide also upon reaction with so HI, 1 mole of HI iodine gets removed. So therefore ethane molecule we will be getting here. Next, so aldehydes reaction with zinc amalgam and HCl. So it is a named reaction, that is Clemmensen reduction. Clemmensen reduction, so particularly used for the reduction of carbonyl compounds into the saturated compounds alkane. Next, aldehydes reduction. So reduction with hydrogen in presence of base. So gives alkanes also. This is a named reaction, that is Wolff-Kishner reduction. So here this carbonyl group, so C double bond O is removed and we are having alkane or ethane molecule. Next, ethyl magnesium bromide is treating with water. So Grignard reagent. This is a Grignard reagent used for a nucleophile, or it can act as a base also. So strong base. So that here from water molecule, so there is no electrophile to be attacked. So it will be acting as a base. So therefore it is ethyl anion abstracted this H plus ion from the water. Therefore also we are getting ethane molecule. So here 2-butane, so reduction with palladium hydrogenation. So hydrogenation in presence of palladium and barium sulfate and quinoline, also a catalyst poison. So it here the reduction or hydrogenation is stopped at the middle of the reaction, therefore partial hydrogenation is taking place here. Therefore particularly, so here the stereospecific reaction, so cis hydrogenation only takes place here. Therefore we will be having, so cis 2 butene we are getting here. Palladium and barium sulfate, this is called as the Lindlar catalyst. Next, so butane, 2 butane, sodium liquid ammonia. So in presence of sodium liquid ammonia, it is giving a trans alkene. Trans alkenes are the major products here. Here radical mechanism, the reaction pass through. So then carbon anion, so two ethane anions are generated here. So therefore they get repulsed. The bond is rotated. Therefore we will be getting trans alkene. Alkyl halide reaction with alkalic KOH. So this is a elimination reaction. So simple alkyl halides, primary alkyl halides undergo E2 elimination. So E2 elimination, therefore it will be giving us, so here from here this carbon hydrogen is removed, and from this carbon halogen is removed. So therefore we will be getting alkene as the major product. Next reaction, so 1,2 dihalides or vicinal dihalides reaction with zinc. So zinc its valence is 2, so therefore it takes up so 2 bromine atoms from the molecule. Therefore so we will be getting ethene as the product. Ethyl alcohol upon reaction with concentrated H2 sulfuric acid at a high temperature 170 degrees centigrade. So dehydration takes place here. So hydroxy group from one carbon and hydrogen from this carbon. Therefore, so two bonds broken. Two bonds are broken. So therefore, we will be getting ethene molecule. So Kolbe electrolysis of so succinic acid, carboxylic acid, salt, dipotassium salt here. So upon electrolysis, so this bond is broken and this bond is broken. So therefore, so radical is generated here. So radical is generated. This radical and this radical gets up alkene molecule or ethene. So this page is covering alkenes preparation. Next, so alkene chemical property, I think. So alkene reaction with bromine. So is giving us, so addition of bromine molecule, electrophilic addition or cyclobromonium ion is formed in the initial step. Then bromide anion is attacked on the intermediate. So 1,2 dibromo, so two bromines adds to the double bond, one bromine on one carbon and one bromine on other carbon. So next, addition of HBr. So this is a alkene, is unsymmetrical alkene. HBr addition, electrophilic addition reaction. So here it follows unsymmetrical alkene and unsymmetrical reagent. Therefore it follows Markovnikov reaction, Markovnikov product. So negative part adds to the, so middle of the middle of the carbon chain. So therefore the positive part, so means in the reagent H plus and Br minus, so negative part adds to the middle carbon. So here Br is attached here and here hydrogen is attached, so I am writing CH3. So this is the Markovnikov product. So Markovnikov product. In presence of peroxide, anti-Markovnikov product is formed HBr addition, same similarly. So here CH3, CH2 hydrogen is added here and bromine is attached or is bonded to the terminal carbon. Next, hydration reaction, alkenes reaction with water in presence of acid medium. So we will be getting hydrogen, one hydrogen to the one carbon and OH is attached to the other carbon. Therefore we will be getting alcohols. Propene addition of borane. So borane is HbH2, we can write it as. So here hydrogen is having a negative charge and boron will be having less electronegative atom, therefore gets partial positive charge, partial positive, partial negative. Here the attachment, the attacking space is the reaction goes through according to the Markovnikov product. So attacking of this H is negative part is middle of the carbon and positive part is towards the terminal carbon and BH2. So these boranes, alkyl boranes are uh, good starting materials for preparation of different types of chemicals or products. So if you treat it with borane, hydrogen peroxide or basic alkali medium oxidation, so BH2 is replaced with the OH. So therefore CH2 and CH2OH alcohol is formed. So terminal alcohol is formed. Addition of borane follows Markovnikov, but so in if you see addition of addition of water molecule, so this is reverse to the addition of water molecule in presence of acid molecule, in presence of acid. Next, alkenes reaction with water hydration in presence of mercury ion, so followed by reducing agent. Here, this is the a reaction addition of water molecule towards the molecule. Here CH2, so here mercury ion is attached here. In the next step, when you add sodium borohydride, that will be reduced. So here in this reaction no carbocation rearrangement takes place. Usually generally electrophilic addition reactions, when there is a chance to form the carbocation, so there is a chance to undergo carbocation rearrangement. Here so no carbocation rearrangement, so due to having mercury ion, so this is the importance of this reaction. Alkenes reaction with the cold dilute alkali KMnO4, basic medium KMnO4. So this is the cis alkene. So we are adding alkali KMnO4. So therefore cis alkene and KMnO4 attached from the cis side, cis orientation, manganate ion will be having like this. So this will be attached to the attacking to on the double bond from the cis side. Therefore cis alkene plus cis addition of hydroxy compound. So we will get meso compound here. Meso compound means having plane of symmetry. So two hydroxy groups acts like this. So this is the meso compound. Meso 2,3 dihydroxy butane diol. Next, transalkene and same similar reaction with the transalkene with the cold dilute alkali KMnO4. So transalkene cis reagent. So therefore we'll be having so racemic mixture. So hydroxy group is attached like this hydrogen here, and its enantiomer. So its enantiomer will be its enantiomer. So together is called as a racemic mixture. Next, so alkene reaction with metachloroperbenzoic acid or peracid, so it will be giving us epoxides. So cyclic oxiranes or epoxides are formed, or cyclic ethers. Next reaction, alkenes. So reaction with KMnO4 in a acidic medium means oxidation. So double bonds are broken here. So here C double bond O ketones are formed, and this is undergo over oxidation. Carbon dioxide is formed here. Next, here so 2 butene undergoing oxidation. So with strong oxidizing agents, 2 moles of carbon acetic acid is formed here. So ozone alkenes, symmetrical alkene, reaction with ozone, so reducing reductive breakage of ozonide further, so will be giving us so alkenes particularly, so with upon ozonolysis gives carbonyl compounds. So C double bond O CH3, and here so this carbon, this one carbon will be forming one carbon aldehyde, that is nothing but formaldehyde. So this is the ozonolysis reaction of alkenes. So this is the third page, so covering alkenes and its chemical properties. Next, calcium carbide reaction with hydrolysis. So it is the C2, calcium carbide is having -2 charge, therefore it will take up so 2 hydrogens. So C2H2 is formed. C2H2, that is nothing but ethane, preparation of ethane. So next, magnesium carbide is having 4 carbon ethanide C3, so that is having C3 -4 charge. So because Mg 2 Mg's develops a -4 charge, so C3H4, so that is nothing but so propine CH3 C triple bond CH propine. Next, vicinal dihalides 1,2-dibromoethane reaction with alcoholic KOH means E2 elimination. So here one time one HBr and another time another HBr, so removed. So therefore, so two bonds are formed in between the two carbons, therefore ethane is formed. Next, so tetrahaloethane. So here can takes place. So two halogens. So we need here two zinc atoms to get two ZnBr to eliminated. So two bonds are broken here. So tetrahaloalkanes upon subjecting with zinc. So also gives us ethane molecule. Next, Kolbe electrolysis. So here means electrolysis means breakage of bond using the electric energy. So here the bond chance breakage of bond chance here. So here radical is formed. So at anode oxidation takes place, at cathode reduction takes place. At anode oxidation means so here this bond breaks up and another two bonds are already there, another new bond is formed, therefore so CH oxidation of potassium malate. So it will be giving us ethane molecule and CO2 carbon dioxide molecule. At cathode, hydrogen gas and KOH is formed. This is the Kolbe electrolysis used for preparation of alkanes, alkenes and alkynes. Next, so next reaction. So here iodoform is there. So in 6 moles of silver, if you add to this molecule, so here elimination of 6 like this, elimination of 6 silver chlorides. So silver iodide, sorry. So iodine, so carbon, iodine, 3 iodines. So silver. So two silver, two silvers, two silvers. So therefore here, so two silver iodates are removed from and make one bond, and two silver iodates are formed is removed to make one bond. So therefore ethane is formed. So finally, next reaction, chemical property, I think alkynes. Alkynes reaction with a metal, so is a reducing agent. So therefore, or it can act as also base also. Here it can take up say, a proton. It will give electrons, and upon which anion is generated, sodium stellite, and sodium stellite plus hydrogen gas is produced of mole. Next, ethine reaction with cupric chloride in presence of ammonical cupric chloride. So here, so copper stellite is formed, a red PPT is red color PPT. So this is the identification test for the alkynes or terminal alkynes. So alkynes reaction with the silver nitrate, ammonical silver nitrate. This is a failing test and this is Tollens test. So here alkynes which gives hydride ion, so that will reduce the silver ion. So silver stellite is formed, a white PPT is also formed here. Next, so ethine reaction with methyl magnesium bromide. So here it can, there is no electrophile, so it will take up a proton from the more Hd carbon, sp carbon. So here HC triple bond MgBr. So this is not the actual product. So methyl gets one proton, so methane is the product formed here. So ethine reaction with the addition of two bromines. So what is the product we are getting? So 2 moles of bromine is attached here, already CHH. So bromine and another bromine, another bromine is tetrahaloethane is formed. So HBr addition follows Markovnikov addition, negative part adds at the middle carbon. So for 1 mole it will be attaching so one bromine atom, so CH2 will be forming here. So in the next mole of HBr, CH3 C bromine CH3 is formed. So here this is called upon one gem dialysis is formed. So accordingly Markovnikov product. Next, HBr addition to the propane. So in presence of peroxide medium, so addition is reverse to the previous case. So CH double bond CH, one hydrogen is added here, negative part is added here. So if you go further, so CH3 CH2 CH, so bromine and bromine, 1 dibromopropane is formed here. So ethane upon hydrolysis in presence of mercury sulfate ion, mercury sulfate. So here addition of water molecule takes place, only one carbon symmetric molecule, so therefore this one is formed, enol is formed. So upon tautomerization, so this hydrogen shift to the this carbon, so therefore CH3, so here carbonyl function is generated here. So this is the next slide, so covering alkynes chapter here. Next, propane reaction with borane gas. So borane is having, so HBH2, negative part is H minus, and BH2 is having partial positive charge. Therefore, this will addition of borane takes place according to the Marconi coefficient only. CH3, C, here negative part is H, and CH BH2 addition. And if you treat it with oxidative hydrolysis and BH2CH3 CH CH, so OH is attached in OH is attached in presence of in place of BH2, therefore enol. So further it will undergo tautomerization to give propanol CHO carbonyl functionality. Ethane reaction with HCN. So here addition takes place on the double bond, triple bond. Sorry. So H, so carbon triple bond. So CCN. HCN is at addition takes place upon the alkyne or ethynes. So therefore CH2. Vinyl cyanide is formed in this reaction. So addition of nucleophilic addition of methanol to the alkyne or ethane. So here CH2 double bond CH, so O CH3 is attached to the ethane in presence of mercury. So vinyl methyl ether is formed. Addition of hypochlorous acid to the ethane, so negative part or positive part, symmetric molecules, no problem. So here, so CH upon one carbon chlorine is attached, another carbon OH, so OH is more negative than chlorine. So here tautomerization, so gives us CHCl. So here carbonyl functionality is generated here. Next, 53 reaction, 53rd reaction, acetylene upon combustion, so any hydrocarbons upon combustion produces carbon dioxide and water molecule, and some heat is generated. Addition of water molecule followed by oxidation, so gives us, so addition of water molecule gives us, so aldehydes. Further it will be give further oxidation, we will be getting carboxylic acids here. So oxidation of alkynes, two butynes with KMnO4 neutral in neutral medium, so produces, so triple bond is broken here, so carboxylic acid is formed here. So here, so KMnO4 oxidation of alkynes KMnO4 in basic medium, so it will be giving us a 1,2 diones. So hydroxy group is attached here, so by removal of one bond, so therefore enol is formed finally. So 1,2 diones are formed in this reaction. So ozonolysis reaction of alkynes produces carboxylic acids only here. So 3 moles of acetylene, 58th reaction, 3 moles of acetylene upon passing through the acetylene gas passing through the copper tubes and red hot copper tubes. So cyclization taking place here, 3 moles of acetylene to give us aromatized product benzene. So 4 moles of acetylene gas in presence of nickel cyanide upon heating, so we will be having a 8 carbon cyclooctatetraene is the major product. So here cycloaddition of thermal cycloaddition or nothing but it's a Diels-Alder reaction. So diene and dienophile, so adds up here. So cyclohexadiene is formed here. So this is the Diels-Alder reaction. 4 pi plus 4 pi 1 4 pi plus 2 pi cyclohexane. It is a Diels-Alder reaction. So 60 reactions completed. Next, aromatic compounds. Carboxylic acid, sodium salt. So benzoic acid, sodium salt. So treated with soda lime. So here decarboxylation takes place. So therefore we will be getting benzene, decarboxylation, soda lime, heating. So phenol reaction with zinc dust. So this oxygen is removed up. So zinc oxide is eliminated. Zinc is eliminated as zinc oxide. Therefore benzene is benzene preparation method. So aromatic amines or anilines. So diazotization reaction produces diazonium salt. If you treat it with so phosphorus acid, so this nitrogen gas is evolved here. So this is also a preparation of benzene molecule. Next, benzene sulfonic acid. So reacted with water. So this bond is broken up. Therefore sulfuric acid is removed as H2SO4. So benzene is formed here. So next, chemical property of benzene. Benzene reaction with chlorine in presence of a Lewis acid. So what is the reaction here? Electrophilic substitution reaction. Chlorobenzene is formed. This chlorobenzene, this chloro group is a ring activating group. So it's a plus Me group which will activate the ring or moderately activating group. So therefore ortho para products, ortho para orientation groups. So this chlorine. So if you react with any electrophilic substitution, if you react with any electrophilic substitution reaction or nitration or sulfonation or halogenation, further for example, if you treat it with again another mole of chlorine, so ortho dichlorobenzene and para dichlorobenzene are formed. Next, 66th reaction. So benzene reaction with HNO3 and H2SO4. So here the electrophile is chloronium ion. So concentrated sulfuric acid, nitric acid and sulfuric acid. Here, so it's a nitration reaction. So here the carbocation is nitronium ion. So we will be getting so nitrobenzene. So nitrobenzene is a minus Me group. Therefore it can act as a meta directing group. So if you brominated the nitrobenzene, so meta dibromobenzene, and upon treatment with tin metal mediated acid mediated reaction with metal, so therefore so NO2 nitro group is reduced to give the meta bromo aniline. Next, 67 reaction. So benzene reaction with concentrated sulfuric acid. So it is a sulfonation reaction. In sulfonation reaction, the electrophile is sulfur trioxide. So therefore, so the product is benzene sulfonic acid. So here it is a minus Me group, strong electron withdrawing group, and which will deactivate the ring. So therefore it can act as the meta directing group. So if you react with chlorination, so if you treat with chlorination reagents, so metachlorosulfonic acid is formed. Any electrophilic substitution reaction. So this minus Me group drives the incoming electrophile towards the meta position. Next, 68th reaction. Benzene reaction. So it's a methyl chloride and aluminum chloride. It's a Friedel-Crafts alkylation. Friedel and Crafts developed this reaction. Friedel-Crafts alkylation. So here the reagent is methyl chloride and aluminum chloride gives the methyl substituted benzene or toluene. So when you treat it with Friedel-Crafts alkylation with the propyl chloride, so here this propyl carbocation is so primary carbocation, so sorry, not resonance. So primary carbocation is rearranged to secondary carbocation. This is the electrophile here. So therefore in this reaction the product is isopropyl benzene. Next, So benzene reaction with acetyl chloride. So it's a Friedel-Crafts acylation reaction. Friedel-Crafts acylation. So therefore, it's a acetyl benzene is formed. Next, benzene reaction with HCN and HCl in presence of aluminum chloride. This is a Gutterman reaction. So here the attacking reagent is ammonium ion. So benzene is attacked on this carbon to give the ammonium ion. So followed by hydrolysis gives aldehyde. Gutterman reaction. Gutterman aldehyde reaction. So we can write it as Gutterman reaction. Next, benzene reaction with carbon monoxide and in presence of HCl and catalyst Lewis acid is aluminum chloride. This is also a Gutterman Koch formylation. Gutterman Koch formylation. So here the product is benzaldehyde only. So these are the reactions of aromatic compounds. Next we go other page 7. So benzene hydrogenation so gives us cyclohexane in presence of nickel catalyst and heating and high pressure and high temperature is needed this reaction. Next, benzene reaction addition reaction in presence 3 moles of chlorine addition reaction in presence of sunlight. So it will be giving us hexachloro addition reaction takes place hexachlorobenzene hexachloro this is called BHC or lindane. So this product is called lindane and 666 or benzene hexachloride. It is called as and also a gamma hexane. It's a gamma isomer of benzene hexachloride. It can act as a so that is used as a pesticide benzene hexachloride. So benzene reaction with lithium reduction with lithium liquid ammonia so gives us a diene cyclic compound. So benzene upon ozonolysis means we will getting carbonyl compounds. So this bond breaks up here. So glyaxal is formed. So if you want a chemical transformation, if you treat it with Clemenson or Wolff-Kishner reduction, Clemenson or Wolff-Kishner reagents, so ethane is produced. So benzene here combustion reaction. So by providing air, so carbon dioxide, any hydrocarbon, we know that carbon dioxide and water is formed and some heat is generated. So toluene reaction with KMNO4 so leads to the formation of the benzoic acid. Any here at least one CH bond is needed. At least one CH bond, at least one hydrogen is present on the directly attached carbon. Then only this oxidation takes place. Benzene reaction with vanadium pentoxide. So we will be getting succinic maleic anhydride. Fumaric anhydride. Maleic anhydride only. So and carbon monoxide is generated here. So coupling reaction benzene aryl diazonium salts biphenyl is formed coupling reaction. If it is phenol also coupling reaction. So ethyl alcohol reaction with HCl anhydrous zinc chloride it is a Lucas reagent. So it is test for the primary secondary tertiary alcohols. So primary alcohols upon heating only gives us a white PPT. So ethyl chloride is formed here. A white PPT after 10 minutes after 1 hour I think. Ethyl alcohol reaction with PCl3 halogenating agent. So this alcohol bond is broken and SN2 type reaction takes place here. So CH2Cl ethyl chloride is means alkyl halide preparation method. So ethyl alcohol upon reaction with sulfonyl chloride. So in presence of pyridine or without pyridine also this goes. So therefore it's also a halogen ethyl chloride preparation. This is a intramolecular nucleophilic substitution reaction. So SNI type reaction. Next slide. So ethyl bromide reaction with sodium iodide It is a Finkelstein reaction, halogen substitution reaction. So this will be replaced by iodide, and it is a SN2 type reaction in presence of acetone. Here solvent based reaction. So acetone is necessary in this reaction. Ethyl iodide is formed. Ethyl iodide. So plus sodium bromide. So the sodium bromide is insoluble in acetone. Therefore, the reaction driving force, the reaction proceeds further. So carboxylic acid, this is a Finkelstein reaction, named reaction. Finkelstein reaction. Carboxylic acid, silver salt. So is reaction with bromine. So it is a Ansdeker reaction. So halogen alkyl halide preparation method. So here it's the reaction proceeds through formation of the radical intermediate only. So here CH2Br is generated. Hans-Decker reaction, initially carboxylate radical is formed, and then this my carbon dioxide is released. So therefore ethyl radical then followed by ethyl bromide is formed. So alkyl halides, so dipole moment is more for the methyl chloride than methyl fluoride. So this is the here chlorine is having, even though fluorine is having more electronegativity, but is having polarity. This bond is more polar than this bond due to size matters here. So nucleophilicity. So the strength of the nucleophilicity in alkyl in hydro halides. So that depends upon the solvent system. So based upon the taken solvent, so the polarity based upon the solvent, the nucleophilicity varies. So in non-polar solvents, so for example non-polar solvents means hydrocarbons, hexane, benzene, so those are the non-polar solvents. In non-polar solvents, so the ion pair means, for example the nucleophile, sodium iodide is there, sodium iodide and sodium fluoride. So here the electrostatic force between them is more, so therefore, so this is the iodine is having more size, therefore it can act as the more nucleophile, the strength of this nucleophile is more than the fluoride. So in polar protic solvents, polar protic means polar water and alcohols are the polar protic solvents. Here hydrogen bonds formed here, therefore fluoride anion is formed hydrogen bond, therefore automatically iodide will be iodide is having no hydrogen bond, therefore its nucleophilic strength is more. So in polar aprotic solvents, polar aprotic means so DMF, dimethyl formamide, DMSO, polar aprotic solvents. So here cation is solvated, therefore small ion, a fluoride ion will be having more nucleophilic strength. So this is the thing. So we have to remember. So methyl bromide reaction with aqueous KOH. So it will be acting as a methyl hydroxide acting as a nucleophile, not as a base here. So substitution reaction, SN2 reaction. So rate of the reaction rate is directly proportional to so alkyl halide strength, alkyl halide concentration, and nucleophile strength, and it's a Walden inversion takes place. Walden inversion in SN2 reaction, Walden inversion, and stereochemistry is opposed here. Polar aprotic solvents, DMF and DMSO type solvents are necessary for this reaction, and it's a tertiary alkyl, tertiary butyl bromide. So here a weak weak nucleophile, and here strong nucleophile is needed for the SN2 reaction. Here things are opposite to SN2 reaction. So is a two-step, here one step reaction, it's a one step reaction, concerted reaction, and no carbocation is formed here. Here carbocation is formed. So carbocation is formed here, sorry. So carbocation, and then it's a two-step reaction, and water molecule is attacked on this both side. Here racemic mixture, if there is a R1, R2, R3 type function groups are there, so racemic mixture is formed here. It's a two-step reaction. So rate is directly proportional to alkyl halide only, and no here racemic mixture is possible if there is a chiral center, and polar protic solvents are favors this reaction, and racemic mixture is formed. and carbocation intermediate is observed in this reaction. It's a two-step reaction. These are the specific characteristic of the SN1 reaction, and this is the SN2 reaction. One has to remember all the points regarding. Ethyl chloride reaction with silver hydroxide. So it is a aqueous medium. So it can act as a nucleophile. So ethyl alcohol is formed. So here nucleophilic substitution reaction KCN. So strong nucleophile. So here Cl is replaced. Ethyl chloride, ethyl cyanide is formed. So here electrostatic attractions and completely dissociated. So therefore potassium ethyl cyanide is formed. Here silver cyanide, it's a soft acid type. It's a soft nucleophile. Therefore bond more attraction will be there, and this is not in completely ionized form. Therefore, so here nitrogen act as a nucleophile. So therefore ethyl isocyanide is formed in this reaction. Ethyl isocyanide. So when comes to the KNO2, so here KNO2, here potassium nitrite, it will be existing as potassium nitrite, so strong attractions. Therefore here when you treat it with potassium nitrate, alkyl nitrate is formed. So when you treat it with it's a strong soft acid and it's a hard base, therefore it is ion type molecule. So here nitroalkanes are the major products. Nitroalkane. So here quite different is there. Potassium cyanide, alkyl cyanide, silver cyanide, isocyanide is formed. When you take potassium nitrite, alkyl nitrite, silver nitrite, you will be getting nitroalkanes. So here another SN2 type reaction, ethyl chloride reaction with ammonia. So HCl hydrogen from here and Cl will be here, will be removed out. So to give us ethylamine. So if you provide further alkyl halide secondary, it's a primary amine. So if you provide further ethyl chloride secondary amine and then tertiary amine like that quaternary amine, this reaction based upon the stoichiometric coefficient, stoichiometric ratios of the reactants. So ethyl chloride reaction with sodium ethoxide. So here it is a named reaction. You should remember. So Wilkinson ether, Wilkinson method. So ether preparation. Next, ethyl chloride reaction with silver oxide, also method for preparation of ether. So diethyl ether is formed. So you can take screenshot. Next we go. So reaction 93, ethyl chloride reaction with magnesium. So magnesium in presence of dry ether. So when metallic reactions are we conducted, so need to be dry conditions. So ethyl magnesium bromide. Ethyl magnesium bromide. It will be having a negative charged carbon anion. So it's a good reagent for chemical transformation. So it can act as a base and as well as a nucleophile. So there will be many applications with this Grignard reagent RMGX. It is also called a Grignard reaction. So ethyl iodide, so with metal reaction, so here metal halogen exchange method. So ethyl lithium is formed and lithium iodide. Here also it can act as a nucleophile as well as base, alkyl lithiums. Ethyl chloride reaction with aqueous KOH is already repeated reaction, aqueous KOH, SN2 type reaction, ethyl alcohol is ethyl alcohol preparation method. Next, ethyl chloride reaction with a nucleophile, series of nucleophiles. It's a sodium estolide, so it will be attacking a nucleophilic substitution. So acetate ion, so the acetate is can act as a base as well as a nucleophile. And here methyl magnesium bromide, it will substitute here. And Gilman's reagent, so it will also produce methyl anion and attack on that one to give propane. So here, so 2 carbons here I am writing, and here 3 carbons, so triple bond product is formed here CC. So ester is formed OCOOCH3. and ethane. So two carbon system. So here CH2 methyl attacked on that substitution reaction, and here CH3 CH2 and this methyl group attached on that one, attacked on that one electrophilic center, nucleophilic center. And here lithium aluminum alkyl halide reaction with lithium aluminum hydride, it is a source of hydride ion, therefore CH2 CH3 is formed. Next 97th reaction, benzene diazonium chloride reaction with cuprous chloride. It is a Sandmeyer reaction. As chloride, copper 1 is taken place. So here chlorobenzene is formed. Benzene diazonium chloride treated with copper powder. So here Gutterman reaction. So it's a preparation method for the chlorobenzene. So another reaction, aromatic nucleophilic substitution. So normally aromatic nucleophilic substitutions without this group minus Me groups, it is not possible. So high temperature and pressure needed. So when you put so these minus Me groups on that one, the reaction is aromatic nucleophilic substitution. So addition elimination type mechanism is observed here, and nitro group. When so as you increase the number of nitro groups, the reaction is very simple and goes in a smooth way. It is aromatic nucleophilic substitution, addition elimination type method. So chlorobenzene reaction with sodium metal, and it's a type of fatigue reaction. So 2 moles of so chlorobenzene so reacted with the sodium metal gives a biphenyl. So Wurz fatigue, it's a Wurz, just it's a fatigue reaction, and chlorobenzene and methyl halide. So it will 2 moles of sodium chloride is removed. So it is a Wurz fatigue reaction. So here methyl benzene is formed. So reduction of steam. So 500 degrees centigrade carbon tetrachloride reaction with water. So that means steam. So it will be giving us carbonyl chloride, nothing but poison gas, is a poisonous gas is produced in this reaction. Carbon tetrachloride with reaction with SbF3 antimony trifluoride here. So CF2Cl2. So freons 1 2. So freon 1 2 is formed in this reaction. Freons, one of the preparation method for the so this can act as a refrigerating agents. Next slide. So phenol reaction with 103 reaction. Phenol reaction with chloroform in presence of base sodium hydroxide. It is a named reaction. So Reamer-Tiemann reaction. So Reamer-Tiemann reaction. So salicylate is formed. So common name is salicylate or 2-hydroxybenzaldehyde is formed. So it's a Kolbe type reaction. So here when you take carbon tetrachloride, so we will be getting carboxylic acid, nothing but salicylic acid. It is called as salicylic acid. So next reaction, chlorobenzene reaction with trichloroacetaldehyde. So it is a preparation method for the here carbonyl group so is substituted with dichlorobenzene like this. So two carbon double bond O oxygen, here this type of bond aldehyde, this double bond O bond is broken, and then so dichlorobenzene is attached to this carbon, and this is called a dichloro diphenyl trichloroethane. So DDT is formed. It's a pesticide. So still in reaction with 2 moles of chlorine, so addition takes place, just a small addition reaction, CH3L2 CH. So 2 moles of addition takes place, tetrahaloethane. So methyl magnesium bromide reaction with formaldehyde. So here there is no acidic proton, therefore it can act as a nucleophile. So it will attack on that one. So CH3 C double bond O minus. So upon hydrolysis it will be taking a proton, and already H is there. Ethyl alcohol is formed. So carbonyl compound reaction with Grignard reagent so gives us primary alcohol. If you take aldehyde here, R group, secondary alcohol, and tertiary alcohols are formed. So again, Grignard reaction reagent attacking on this epoxide or cyclic ethers. So this ring is open up, and here we will be having this carbon, and this carbon is going to be formed a bond. So CH2 minus MgBr, upon hydrolysis OH is formed. Next, 107th reaction. So acetaldehyde, aldehydes reduction with reducing agent, hydrate source LiH4, sodium borohydride, and zinc acid medium zinc reduction, or sodium ethyl alcohol. So gives us carbonyl is reduced to alcohol. So reduction of cinnamic acid. So this is we need to remember cinnamic acid. This is crotonic acid. Reduction with lithium aluminum hydride. Generally, acid group is only reduced, but here in when there is a phenyl ring is in conjugation with this double bond, this double bond will become labile. So therefore, double bond also gets reduced here. CH2OH. So here there is no resonance, double bond is stronger, so therefore CH2OH alcohol is formed only. Double bond is not disturbed here. Ethyl amine reaction with diazonium salt formation type reaction. So primary amine, so amine forms diazonium salt, and then reaction with water. So nitrogen is evolved here. So therefore, so ethyl alcohol SN1 type reaction takes place here, carbocation, and followed by addition of water. So ester, this is a ester compound. Hydrolysis of ester gives just a acid, simple reaction, carboxylic acid, and this part this part alcohol is formed. Next, 1/10th reaction. So sucrose reaction, hydrolysis of with invertase enzyme. So we will be getting a glucose, and then zymase, upon reaction with the zymase enzyme, so we will be getting ethyl alcohol. So alcohols chapter. So starch upon hydrolysis, so with the diastase enzyme by adding a malt, barley malt, so we will be getting maltose, a sugar disaccharide. So upon reaction with the maltase enzyme, treating with maltase enzyme, so we will be getting a glucose. Here glucose treated with the zymase enzyme, so gives us ethyl alcohol, C2H5OH alcohol preparation. So this is the up to 1/11th reactions. Next, reduction reaction, carbon monoxide reacted with more amount of hydrogen gas. So here it will be giving us a methyl alcohol preparation. So benzyl chloride reaction with aqueous KOH, it is a nucleophilic aromatic nucleophilic substitution reaction. Aliphatic nucleophilic substitution only. So here carbocation is generated here, more stable carbocation here formed. So therefore it will, that is called a SN1 type reaction. So wherever there is a stable carbocation is formed, that reaction is called SN1 type, that will undergo SN1 pathway rather than SN2. So alcohol acidic proton is there here, it can act as a base, therefore alkoxide is formed, CH2ONA, hydrogen gas is produced half mole. So alcohol, a primary alcohol having tertiary carbon, so acid medium, acidic medium, so and heating also there. Therefore here, so oxonium is formed, and then next step that is eliminated. Oxonium carbocation is generated. This is a primary carbocation, and which is unstable. Therefore here hydride is shifted there. Therefore not hydride. So here ring expansion takes place. So 6-membered ring is formed, and then carbocation is retained there. So here H minus is eliminated. Therefore cyclohexene is formed. Secondary alcohol with tertiary carbon. So there is a scope for acid medium rearrangement type reaction. So oxonium is formed, and then this type of carbocation is formed. Here one of the methyl group, secondary carbocation, will be converting into the tertiary carbocation. So therefore So here this methyl, new methyl group shifted, here carbocation is there. So already two carbon, three carbons upon this carbon, tertiary carbocation, and then HCl. So Cl minus will be attacking on this one. So here this type of product is formed. Next, alcohol oxidation. So initially, upon partial oxidation, it will take with alcohol, then aldehyde. So aldehyde, then further oxidation. Since it is a strong oxidizing agent, acid is formed. So alcohols upon treatment with the copper. So it will be oxidation takes place, one hydrogen from here and another hydrogen from here. Removal of hydrogen also called as the oxidation. Aldehyde is formed. Secondary alcohol ketone, tertiary alcohol alkene is formed. This is the test for the differentiating alcohols reaction with the copper metal. Allylic alcohol reaction with a mild oxidizing agent. So oxidizing agent means removal of hydrogen. So both hydrogens removed from that one. Therefore, this type of compound is formed. Acrolein. This is acrolein. A good reagent for the starting material for the Diels-Alder type reactions. So here another named reaction, it seems to be secondary alcohols, aluminum isopropoxide and ketone as a solvent here. It is a open air oxidation. Open air oxidation. Here acetone. So this type of ketone is formed. Acetone reaction with halogen and sodium hydroxide. So here it's a yellow form test. Yellow form test. So methyl ketones gives a halo forms. So three hydrogens are substituted with halogen CX3. So that is like this. So remaining part forms a salt CH3COONA. So alloform, for example, if you take chlorine, so we will be getting chloroform. So if you take iodine, so we will be getting iodoform or bromoform. So take secondary alcohol, next reaction. Secondary 120th reaction, 122. So secondary alcohol is having stereochemistry is referred fixed here. SOCl to SN intramolecular nucleophilic substitution type reaction. Here nucleophilic substitution OH is detached here, chlorine is replaced, substituted. So with having stereochemistry retained, so when you take in presence of pyridine, the reaction is the stereochemistry is reversed. It's a SN2 type reaction. It is a SN2 type reaction and it is a intramolecular SNI type reaction. So this is the specific characteristic of this reaction, SOCl2. Next, 123rd reaction, alcohols chapter, I think. So alcohol is converted into the alkyl halide. It's a Victor Mayer test. So test for the primary, secondary, tertiary alcohols. So it is treated with HI. So alkyl iodide is formed. H2O is eliminated. Alkyl iodide is formed. So we know that it is a ionic compound, silver nitrite. So RNO2, nitroalkane is formed. So which is reacted with for example RCH2NO2 type compound is there. So if it is a primary alcohol, then primary nitroalkane is formed. So when you treat it with nitroalkane with HNO2, RCH NO alpha substitute of alpha position is substituted with nitroso group. So therefore when you treat it with alkali sodium hydroxide treatment with so it will be converted into the red color. If it is a secondary nitroalkane, so blue color is, if it is a secondary, it is a blue color, and if it is a tertiary, so there will be no reaction, no color change is formed. So this is the identification test for the primary, secondary, tertiary alcohols. Next, reaction of glycols, reaction with halogenating reaction. So here HCl or PCl5, PCl3 or SOCl2. So alcohol, we know that alcohol group is hydroxy group is substituted to give halogen derivative. HI phosphorus is a reducing agent, so reduction takes place. So here, so this group is attached and that group is detached, so ethane is formed. Phosphorus iodide. Phosphorus iodide means iodizing agent, iodination. So CH2I and CH2I. So iodo compounds are unstable. Immediately carbon and iodo bond is broken to give ethene as the product. So zinc chloride. So zinc chloride is a dehydrating agent. So water is eliminated. Zinc chloride. So therefore vinyl alcohol is formed. So CH2 dehydration. Vinyl alcohol nothing but so leads to the ClO aldehyde. So concentrated H2SO4, so similar reaction, aldehyde is formed. So periodic acid, so HiO4, so the CC bond, glycol splitting agent. So whenever there is a 1 comma 2 dihydroxy compound is there, so glycol, that is called glycol, that is split, that CC bond is broken up, and aldehyde HCHO. So alcohol, this bond is broken, and aldehyde, this aldehyde and this aldehyde. So therefore 2 moles of formaldehyde is formed. So similarly, it's a glycol, ethylene glycol. So here glycerol. So glycerol. So glycerol are the products of the hydrolysis products of the fats and fatty acids. So when you treat it with similar type of reactions, halogen derivative is formed. So this hydroxy groups, when you treat it with halogenating agents, so trihalo 1 comma 2 comma 3 trihalo alkane. So phosphorus triiodide means 3 iodine compounds. 3 iodine groups are substituted by hydroxy. 3 hydroxy groups are substituted with iodine, and iodo and are upon adjacent carbons unstable. Therefore, so one iodine molecule is eliminated. So one of the iodine is retained on the carbon only. Concentrated HNO3. So hydroxy group is converted to the nitro group. So that is glyceryl nitrite. So remove hydroxy and put NO2 3 nitro groups. Glyceryl nitrate, triglyceryl nitrate is formed. Oxalic acid. So when you treat it with oxalic acid, so directly we have to remember formic acid is formed here, and carbon dioxide. So oxalic acid reaction with glycerol reaction with oxalic acid at 260 degrees centigrade, we will be getting allyl alcohol. Allyl alcohol means vinyl having CH2OH. Next, so potassium bisulfate, elimination of water from this any two carbons, adjacent carbons, therefore also gives us dehydrating agent, allyl alcohol is formed. So periodic acid, so glycol split agent. So here this bond is broken up. Terminal carbon primary alcohols converted to the aldehydes, 2 moles of formaldehyde. Middle carbon is subjected 2 times oxidation. Therefore, that will give one acid, carboxylic acid, formic acid. So this is same 1:3 types of glycerol, 1:3 moles of HI. So it will also give allylic iodide. So these reactions covers from the alcohols chapter. Next, almost 1 hour is completed. Yeah. So alcohol reaction with concentrated H2SO4 at 400 degrees centigrade. 413 degree kelvins. So converted to the at low temperatures, it will be converted to the ethers. So diethyl ether at high temperature with the same reagent concentrated H2SO4. So will be dehydration takes place. Alkene is formed. So phenol reaction with sodium hydroxide. So acid base reaction. Sodium phenoxide is formed. So upon reaction, this is the oxide ion nucleophilic type reaction. So ether is formed. Next, diethyl ether, ethers chapter. Ether reaction with concentrated H2SO4, hydrolysis takes place. We will be getting ethyl alcohols. Ether reaction with HCl, so we will be having ethyl alcohol plus ethyl chloride. Ethyl chloride. Ether reaction with cold HI, so cold means ethyl alcohol plus ethyl iodide. Excess HI, we will be getting 2 moles of ethyl iodide only. Ether reaction with so unsymmetrical ether but smaller groups, so HI. So iodo group H iodide nucleophile will be attacking on the smaller group, so methyl iodide, so steric less side iodo large bulkier iodo nucleophile goes and C2H5OH is formed. So whenever there is a bulky alkyl group and there is a chance of formation of carbocation type, so here SN1 type nucleophilic substitution reaction takes place. So here this carbocation, here the carbocation is very unstable, therefore that is SN2 type. But here SN1 type reaction, so this carbocation is generated, and this iodo group goes to this carbon, more bulkier carbon, after formation and detachment with this ether bond. So tertiary butyl alkyl halide, tertiary alkyl halide, and this smaller group will goes to the methyl alcohol. When there is a small alkyl groups, smaller alkyl group goes to the iodine goes to the smaller methyl smaller group. When there is a chance of formation of carbocation, SN1 type of nucleophilic substitution takes place here. When there is a aryl ethers, so nucleophilic substitution cannot be taking place from here. Smaller group side only. This is carbon aromatic ring and oxygen is having in resonance. Therefore, OH methyl iodide. Yeah, next. Ether reaction with chlorine dark medium. Sorry, alpha halogenation. So here this is alpha alpha halogenation. So one alpha here, one of the hydrogen is substituted. When there is a reaction with in presence of in presence sunlight, all hydrogens are substituted. Here only in dark medium, only this alpha hydrogen, only two alpha hydrogens only substituted. So here all the hydrogens are substituted in presence of sunlight. So ether reaction with oxidation in presence of air, so peroxide is formed. Alkyl peroxide. Ether reaction with steam hydrolysis, so ethyl alcohol, sorry, steam, it will be forming ethyl alcoholic, ethyl aldehyde type of reaction, acetaldehyde is formed, oxidation type reaction. So PCl5 ether reaction with ether reaction with PCl5 halogenating agent, so ethyl chloride. Ether reaction with carbon monoxide in presence of acid, insertion type of reaction. So here C double bond O ester compound is formed. Ether reaction, sorry, here alcohol only, CH2OH. Ether reaction with oxidizing agent potassium dichromate, so here we will be getting aldehyde is the product. So this page covers the ethers chapter. Next reactions. So ether dimethyl ether, so reaction with HI, 2 moles of HI means methyl iodide. So silver nitrate means silver iodide. So here this is the uh, Jaisel method for the for knowing the number of methox group in a compound. First reaction with HI and then methyl iodide. It's a Jaisel method. Jaisel method to know the number of methox groups in a compound. First I reacted with hydrogen iodide, so compound is methox ethers are converted to methyl iodide. Then silver nitrate, silver iodide precipitate is formed. Accordingly, the number of moles formed silver iodide can be considered. So here chlorobenzene aromatic nucleophilic substitution reaction. So chlorobenzene sodium hydroxide, it's a Dow reaction. So for the preparation of phenols, so sodium phenoxide, and then treated with acid, it is giving us phenol. Benzene diazonium chloride reaction with warm water will be giving us phenol. Benzene sulfonic acid reaction with sodium hydroxide, so it will be giving us sodium phenoxide, and then treated with water, phenol is formed. So cumene reaction with oxidation, and cumene peroxide is formed here. So reaction with oxygen. So further in presence of acid medium, so this will be undergoing rearrangement reaction. So acetone is formed here. So it's a Dawkins reaction. So aldehyde is treated with aldehydes are converted to the alcohols. So phenol benzoyl chloride reaction. So it's a Schotten-Baumann reaction. So this benzoyl chloride is removed out. Benzoyl phenyl benzoate. So salicylic acid reaction with acetic anhydride, so it is giving us a acetyl salicylic acid, COCH3. Acetylation takes place here. Phenol reaction with ammonia, so will be giving us aniline. So phenol reaction with potassium protesulfuric acid give us a quinol. So phenol reaction with chromic acid reaction with giving us a quinone. So these are the chemical reactions. So we are studying in the next slide. In the next video we will be covering another 60 reactions, which covers all the 200 reactions, which covers 11th and 12th classes organic chemistry. So almost 1 hour 15 minutes it has taken up, and another 60 reactions will be coming in the next video. So thank you. So I hope so if you revise all these reactions, if you able to write the products like this, and your organic chemistry is fulfilled, and GOC also 10 concepts taken in the next video. So thank you so much. So I hope you all enjoy this video, and I hope you will share this video to your friends, and for thank you friends.